I put those online for you, right? Those were online. So 1, 2, 3, 4, and then 9, 10 or something. All right, let's take a look here. So how to do number 5. So how do we do this problem? So let me encourage you, if you haven't made your 3x5 card, make it right now. Even just rip out a piece of paper that's about 3x5, and put the important things you need on the front and the back of it. So a lot of the battle is identification. When you look at number 5 and number 6 and number 7, something in your mind should say easier. I mean, none of them are super easy, but I mean easier than the other ones. Why? Why would you look at 5, 6, and 7 and think generally not terrible, a little easier than some of the other problems on the test? Why? What's easier about them?
You don't need a common.
Multiply and dividing don't need common denominator. Perfect. You two put together, perfect. Exactly. Are you aware of that? That's one important thing. When you have multiply or divide, those are the kind where you don't have to mess around with the common denominators and give them what they're missing and LCD, canceling. All that not needed. All that's not needed. When do you need that? When do you have to get common denominators and do all that messed around? Adding, subtracting. So is that big divide clear in your mind? Right? So for adding, subtracting, LCD is needed, and those are the painful ones. It take a lot of work, give them what they're missing, all that stuff. Right? But if you're multiplying divided, no LCD. Just factor and cancel. So for multiply divide ones, no LCD, just factor and cancel. They're really just glorified factoring problems. Just factor everything and cancel out. Those should be the easier ones on the test. The multiplying, dividing. Okay, so let's see how that works. So for number 5, first off, and by the way, there's nothing to factor. When I say factor, do you realize why is 6 need to be factored but 5 does not? Why do I look at 5 right away and say doesn't need to be factored, but 6 I go does need to be factored? Pluses and minuses. Yeah. Do you see how the plus and minus versus the multiply divide? That's a big deal, isn't it, as far as which road we take at different times, huh? It's a lot of the identification battle, which is a lot of the crucial battle on a math test. When you see this adding, subtracting, you go, oh, got to factor those guys. Right? Whereas up here, look, there's no adding, subtracting anywhere on number 5. Nothing needs to be factored. So factoring is when you have adding, subtracting. Okay, so now I hope I didn't just confuse you because I said multiply in the middle means no LCD. Right? This says multiply. Even number 6 has multiply in the middle. Number 7 has divide in the middle. No LCD on any of these. But 6 and 7 do have adding, subtracting in the numerator or in the denominator. Not in the middle, but in the numerator or denominator. So the this needs to be factored. That needs to be factored. Everybody seeing that? So basically, long story short, you know the way there's so many rules in algebra, so hard to keep it all straight. One overarching rule that'll help you in a lot of situations is adding, subtracting is hard. That's not an official rule. You won't find that in a math book. If I ever wrote a math book, I'll never write a math book. But if I ever wrote a math book, I would put that in there because that helps in a lot of situations. Adding, anything hard, it's always because of adding, subtracting. Pretty much always. So when you look at this problem, number 5, you should look at it and go, look, there's only multiply. There's no adding, subtracting anywhere. It's going to be an easy problem. When you look at number 6, you should think, okay, it's basically multiply, so it's basically easy, but I got adding, subtracting here. Also, that means I need to factor this part, which is kind of a pain. And I got to factor this part, and I got to factor this part, because they have adding, subtracting. So notice the hard stuff is always because of adding and subtracting, isn't it? Adding, subtracting makes us do all the hard things. Okay, so coming up here, let's actually do this problem. So look at it, number 5. No adding, subtracting anywhere. So it's easier problem. What do? Just cancel stuff out. Just cancel stuff out. What do I mean? What do you do with z cubed over z squared? Subtract them, cancel them, however you want to say it. It really means there's a 2 and 3 z's on the top, and there's 2 z's on the bottom. 2 of them cancel 2 of them, don't they? And there's 1 z left on the top, or you could just subtract the powers, same result. A single z and the number 2 left on the top. Actually, though, that number 2 will go into that number 4 2 times. Now, you might think, well, shouldn't we have gone 4 into 16? You could have. You can start anywhere you want. Yeah, if you want to do that instead, here, I'll go back. That's probably easier. Probably you're right. Either way, though, 4 goes into 16 4 times. That's good. The leftover 2 on the top, the leftover 4 on the top make 8. And the single z, 8z. See? Is that good? So only cross-canceling required on that one. I just cross-cancel, diagonally cancel. Leaves a 2 and a 4 on the top and a z, 8z on the top. Questions on that one?
And you could cancel this way on that.
Straight up and down. Yeah, let's redo it that way.
There was something there.
Totally. You can go straight up and down or diagonal. Good question. Danielle's right. You can cancel straight up and down or diagonal. Either way is okay. So I could have gone 2 into 4 2 times. Right? Now that 2's gone. He's not there anymore if I go this way. And then what would I do with this 2 now? 2 into 16? 8 times. See what we end up? Same thing. See how it's the same result in the end? Either way. So you can go straight up and down first and then diagonal if you want. That works. Or you could just go 4 into 16 4 times and then 2 times 4 is 8. So things that are both on the top multiply. But top to bottom cancel. Either straight up and down or diagonal. Either way, top to bottom cancel. Both top multiply. All right. So either way, it's going to be 8z. Okay. Next problem, number 6. So we see adding, subtracting. We think, oh, that's hard. Always hard. Adding, subtracting. Got to factor. So let's factor this one. Remember how the factoring, you guys are good at factoring. Seen a lot of good factoring. They multiplies to be 15, adds to be minus 8, huh? Right? We always multiply to be the back number. So what's that going to be? X is in the front. What times what makes 15? 5 and 3, 3 and 5, either order. And how do you get minus 8? What sign? Remember the middle always tells you how the signs go? Minus 8 in the middle. What signs do I need in the 5 and the 3? Both minus, huh? Because if you lose $3 and lose $5, you lost $8. And the two negatives do multiply to be plus 15, don't they? Two negatives multiply to positive. So that part's good. Question?
When you have a subtraction, can the two x squares, can you cancel those?
Good question. Yeah. What do y'all think? That's a really good question. Can I cancel those x squareds?
No, because it's attached.
Because of the plus and minus Costco glue thing. Again, plus and minuses make things hard, huh? Yeah, right. So it's not allowed. Good question. Because of this minus sign right here, the x squared says, whoops, I'm scribbling that. The x squared says, hey, I'm glued to that 25. If you want to cancel me, you cancel all of me or none of me.
So you can cancel the x5, you can factor that and then cancel the x5, right?
Yeah, we'll do some of that. We will factor, then we'll do some canceling. You're right. But as it stands right now, we cannot cancel because pluses and minuses glue things together like Costco package deal. You buy the whole package or nothing. You can't say, well, I just want the x squared part. I just want to cancel the x squared part. No. X squared minus 25, package deal. All or nothing, right? So that's by the way, why we're forced to factor. Because we got to break up the package. So x's. What multiplies to be 25? 5. How do the signs go for negative 25? 1 positive, 1 negative. Right, you're used to that one, right? 1 positive, 1 negative makes negative 25. And then how about, what do we do with the x squared minus 3 thing? Pull out an x. Yeah, good job. It's GCF, huh? It's take out what's in common. Good. X times x minus 3. If you were to distribute that, it would go back to x squared minus 3x. All right. All 3 parts are factored. Now we can cancel. So now, I don't know if this is confusing. Just forget about this, forget about this, forget about this. The x squared, so yeah, maybe it'd be better if I rewrote it. So what do we have? We have x squared. We have x minus 3, x minus 5. That's a 5 there. And on the bottom we have x plus 5, x minus 5, and x minus 3. Everybody see? So these two went here, this went there, right? This x squared's here, these guys are here, right? There's everything. Now we can just cancel away. Now everything's factored, isn't it? So now we can just cancel anything that matches. So X minus 5, X minus 5, X minus 3, X minus 3. Anything else we can cancel? Yeah, this X cancels, leaving a single X on the top. So we're left with a single X on the top and an X plus 5 on the bottom, huh? Like that? Everybody good? And can I cancel these X's at the end?
No, because they're a package deal.
Because the bottom's a package deal. You buy all of it or none of it, so we're done. So X over X plus 5, there it is.
So what was your, so you still have that X squared?
Yeah, this guy,
Yeah, okay.
he was still there.
Yeah.
Right, good. It's easy to lose him in the middle of all the other factoring. Yeah, right, so that X squared was there. And that canceled with one of the X's on the bottom to leave just a single X on the top. Good with all that? So pluses and minuses are the hard part. We always got to do something hard. We got to factor them and stuff. All right, ready to go on to number 7? All right, number 7. Now there's divide in the middle. What do we always do with divide?
We flip it.
Yeah, keep. What is it?
Change flip.
Keep, change, flip. Yeah, keep, change, flip. So keep. So for divide, you use the rule keep, change, flip. So you keep the left side as it is. Change, divide, and flip the right side.
And we're pretty much doing the same thing as the last problem, right?
And then we do exactly the same thing as last. Now we just factor those 4 pieces and cancel. But first we had to flip. First we had to keep, change, flip for divide. So everybody good with that? So for divide problems, keep, change, flip. You always have to flip the one on the right for a divide problem. Keep, change, flip. And yeah, now it's just like the last problem, huh? Which was a times problem. And what's the hard part? All the parts with the pluses and the minuses. All those parts need to be factored. So let's start with this one. He needs to be factored. Couple parentheses. So what multiplies to be 10 adds to be 7. Yeah, plus 5 plus 2. Everybody good with both pluses on that?
Yes.
So you got to make plus 7 multiplied to be 10 over x plus 5 times, and then on the right side, how do we factor 5x minus 10?
5 out on the outer.
With x minus 2? Good. And then how do we factor x squared minus 4?
X minus 2, x plus 2.
Yeah. X plus 2, x minus 2. Good? Yeah, Shimani.
If you didn't flip it, you would still get an answer, but it wouldn't be right.
Right, parts of it would be in the wrong spot. Yeah. Gotta remember to flip on divide. Yeah. There'll be one divide question. Just remember to flip. So those cancel. And x plus 2's cancel. X plus 5's cancel. What's left?
5.
The 5. All that is 5. It's B again. Has it been B every time?
No.
B. Almost, huh? Last two? B. If in doubt, choose B. No, not a good plan. Good. So everything canceled? All right, shall we move on to number 8?
Yes.
All right. LCM. Now, is there any pluses or minuses here? No, so nothing needs to be factored. They're good as they are. Don't got to mess with them. I just got to do the final answer still. But I don't have to mess with them first because there's no pluses or minuses. You see in that repeated theme, plus or minuses mean you got to do more work. So there's no pluses or minuses. So we just got to do the LCM. How do we do the LCM? What do we do?
The stairs.
The box, stairs, cake, whatever you want to call it. You got to put the 15 and the 25 in the box thing, huh? The L box for LCM. Remember that? And say, okay, what goes into 15 and into 25? 5 does. 5 goes in there 3 times. 5 goes in there 5 times. What goes into 3 and 5?
3. 1. That goes into 3.
Yeah, but it's got to go into both, though. So nothing goes into both, right? So we're done. So where's our answer? You times them, huh? You times these guys together.
Yeah, 'cause I
75.
where I have it, I get to the 1s, and then I just multiply that.
That'll work too. So 75 is the LCM or LCD, same thing. So 75, of course, what did that get us? They all had 75. I don't know what that helped. But anyway, 75. All right, we agree. 75. And now what do you do with the letters?
Take the highest power.
Yeah, highest. We good with that? So the highest x is actually the x squared, isn't it? And the highest y is the only y, the plain y, right there. So x squared y. 75 x squared y, c. So when it comes to the letters, we take the highest of each one. Remember that? That's the shopping. All my analogies are shopping, it seems like. But anyway, I rarely go shopping. But that, yeah, so you're taking the highest of each kind. Highest. And that's funny because the L stands for lowest, doesn't it? Lowest common multiple or least common multiple or denominator. But we actually take the highest of each letter. There's a logical reason for that, but we don't have time. Just remember that. Just help you memorize it that way. For the lowest thing, you take the highest. Reminder, today is test day. LCM, but this one has pluses and stuff. So what does that mean? Got to factor them first, huh? See how this is different than the last one? See, those pluses are saying, I'm a harder one. You got to do some more work first on this one. Like that. Okay, so let's do this one first. Because did you notice that little comma in between them there? That comma is separating them. So let's do this one first. How do we factor this one? It's the two parentheses. R and R. Yeah, 8 and 8. Plus 8, because that'll multiply to be 64, add to be 16, won't it? Mm-hmm. And what do you do with identical twins?
R squared.
You got to put two on the parenthesis, huh? Is that good? Okay, now for the second one, for this one, now we got to factor that one, put a comma, factor that one. How do you factor r squared plus 8r? Is it, okay, how about this? Could I do it this way? R plus 4, R plus 2. Won't that work too? That's wrong. I hope you know that's not right. I see that mistake a lot. Couple things that's not correct. Couple things to help you not do that. First thing is, you only do the two parentheses when you have three terms. Well, that's not entirely true, is it? Or you're squared. Yeah, so that's, yeah. But basically, here's the best thing. Always look for GCF first. And every problem, you should first, before you jump to anything else, ask, is there something in common? That's always the first question you ask. And when you do that, when you see something coming, you go, oh yeah, they both have an R. That'll keep you from making this mistake. You go, oh yeah, they both have an R. Well, then do that first. Take out the R. That leaves R plus 8. Everybody say that. So that's always the first question. Before anything else, is there something in common? Even back on that last one, R squared plus 16R. I should have asked that. I should have said, do these three have something in common? Do they all have an R? No, the 64 doesn't have an R. Do they all have a number? No, the R squared doesn't have any number at all in front of it. So no, there's nothing in common. Then I dove into the two parentheses, right, when I saw there was nothing in common. But always look for commonness first. All right, anyway, so we're to here now. Now, what's the LCM? Least common multiple, we actually take the greatest of every type of item, right? So a single R and an R plus 8 squared. So I grab this one here and that one there, don't I? So remember what you're doing. You're going to the store, you're buying one of everything, the most expensive one, the highest one. Right? Even though it says lowest, that's how I survived college, by goofy little memory tricks like that. I'd go, okay, well, it says lowest, but I do highest. It says lowest, but I do highest. And then it helped, you know. Then I forget it the next day. But lowest to highest, there was some of that, truthfully. All right, so if it works for you today, lowest common number, you grab the highest R plus 8, the highest only R. All right, number 10 we did, right? So let's pick it up. 11 is like the worst, isn't it? It is the worst. So what do we do here? It is. It's got a lot of tricks in it. Yeah, we'll talk about that. What do you do with this first off? Yeah, right. You can factor it if you want right now. Yeah, that's another good way. I'm just going to take out an X at first. And then I go, oh, look at that. Remember, we never want the letter subtracted at the back in the denominator. It's okay in the top. It's not okay. And we don't, you might wonder what yeah, I feel like there's so much to tell you, to be clear, but the denominator is our focus right now. If I had that in the numerator, I wouldn't care. Why? Because what's in the middle? How do we know it's going to be a hard problem? That plus sign, huh? That plus sign in the middle means this is a hard problem. Common denominator required. You've got to make the bottoms the same before you can add them. Everybody getting clear on that? Pluses or minuses in the middle, right? Just like number 12 also, minus in the middle. So this is way harder than those ones we just did that just had multiply, right? Look back here. See this, well, it's 2 pages back. See how this had divide in the middle? This one had multiply in the middle. Those were easier problems. When they have add, subtract in the middle, they're harder. You got to get a common denominator. So all of my focus is the denominator. Look at that denominator. The x is subtracted at the back. You got to fix that. What fixes that? What do I mean fix it? In fact, let me first bring it over here. X. How do you factor x squared minus 1? You know. X plus 1, x minus 1. Everybody good so far to there, right? That's right so far. Anything plus or minus, you got to factor. Denominators. I don't care about the numerator. On these problems that are adding, all of my focus at the beginning is on the denominator. Because I need common denominator. I'm not even looking at the top. I don't care if there's a funny monkey up here. Who cares? Whatever. I'm not even looking at the top. All of my focus is in the denominator until I can make the bottoms the same. As soon as I've made the bottoms the same, then I'll turn my attention to the top. Right? Have you seen that pattern? It's all bottom work until you've made them the same, then you go to the top. So, just so you're not tempted to do something fancy in the top. We don't mess with the top until the bottoms are common, right? So, all right, so we got to make those bottoms common. How do we do it? Well, there's the problem. We can't have the letter subtracted at the back. What fixes that? You multiply top and bottom by minus 1. That's what fixes it. Remember that? What does that do exactly? Well, let me just rewrite this first one. That makes the top minus 8x, right? Minus 1 times 8x. The bottom, it skips over the x and just hits this guy and turns him around. Yeah, I know there's so many things to explain. Okay. Yeah, no, that's a good question. I'm just nervous that I won't have time to explain everything. If you're multiplying 3 things, think about that for a second. That's what this is. This is 1 thing, 2 things, 3 things, timesing. What is the truth about multiplying 3 things? You actually know it. How do you multiply 2 times 3 times 4? What do? You just go 2 times 3 is 6, times 4, 24. No big deal, right? What if you instead let the 2 go over there and hit the 4 first? Would that have been okay? Totally. 2 times 4 would be 8, and 3 times 8 would be same answer. So the first lesson, do you see that when you multiply 3 things, it doesn't matter what order? You can let this guy skip over and hit the third guy if you want. It doesn't matter. They all make the same thing in the end. They're just all going to multiply. It doesn't really matter what order, huh?
Why isn't your x negative? If you're multiplying it by...
Yeah, because, good question. So everybody, study with me these numbers. Everybody see what's happening with these numbers. I can multiply the first 2, and then the last one, or I can multiply the first and the last, and then the middle one. Whatever. Same thing. When you're multiplying 3 things, the order matters not, right? So with that clear in your mind, that's what this is. This is 3 things. So I could just do the first with the third. That's totally fine. Now, so I'm never multiplying the first with the second, am I? I never took minus 1 times x. That's why it's not a minus x. I'm thinking, I'm not interested in hitting the middle one. He's not the problem. The one at the back is. The one at the back has the x subtracted to the bottom. So that's why I'm bringing in the negative 1. It's for him. So I let him go to him. And when he hits him, what does he do? Well, he makes this negative 1 plus x, right? The minus 1 hits that. Make negative 1 plus x, what is that? X minus 1. You just turn it around. That's x plus negative 1. That's x minus 1. Do you see that really... You don't have to show all that. I'm just showing you it's really true logically. That's really what it does. And it's really consistent with what we've always known about numbers. It just might not have occurred to you. That's always what we've done with numbers. The order of multiplying 3 things has never mattered. Make sense? So that's true? Yeah, I could have put it on the 8 or the x. I just put it on the 8. Right. That's exactly what I did in the top. Yeah, it carries the negative, right. On the bottom, I just said, well, I'm only going to put it on the 1 minus x. It changes both signs, which effectively flips it around. So with all that, I know, So some of you, it's always tricky as a teacher. Some of you want more detail, and some of you are like, I don't want to know that stuff. That's just confusing me, Mr. Aaron. So I'm kind of mixed in my response. So let me go back to the quick, short, clear way without all that detail. Basically, multiply top and bottom by -1. Just let that guy hit this guy. It turns him around. That's what it does. You don't have to worry about anything else if you didn't follow all that other detail. That'll work every time. Okay. Yeah?
You can also just turn around right at the beginning, like it's just x minus x.
You could have. Totally. Yeah. You could have done the turnaround right in the beginning when you saw it coming. So look, he's got the higher power at the back. We can't do that. Multiply top and bottom by -1. That would flip it around right away. And then it would eventually factor to be this anyway. Totally.
That makes no sense.
Either way is good. Either way you like. All right. So, yeah, if you like that better, yeah, does that make sense? Right in the beginning, yeah, maybe that's better. So the higher power at the back, right away in the beginning, maybe if that's easier for you. Just right away, hit it with a -1, top and bottom. That turns it around to be this order, and then just take out the x. See, that's what I eventually got through my more convoluted way. Whichever works for you. So you don't want higher power subtracted. Why do I keep saying subtracted? What if it was added? What if that was x plus x squared? You can just turn it all day long. Who cares about the order of adding? That's just a looks thing. You can just flip that all day long, right? But minus, that matters. You got to do something about that, right? Does everybody see that? So yeah, probably best just to multiply top and bottom by -1 right in the beginning. Flips it around. All right, now we're to here. Now, what do we do on this problem? Remember our goal. We've got to make these bottoms the same. We've got to make them the same.
So what gets back?
Give them what they're missing, right? Remember that whole give them what they're missing thing? So let's do it. So top and bottom, what they're missing. What's this missing that the other one has? Plain x. What's this guy missing that the other one has? X plus 1. X plus 1. Everybody see that? See how the two denominators have the same 3 identical pieces now. I've made the bottoms the same. They both have a solo x, an x plus 1, and an x minus 1. Solo x plus 1, x minus 1. The two denominators are common now, which means I'm done with the bottom. Now I'm going to turn my attention to the top and just multiply out the top and gather like terms. Getting the hang of that? See how this process works? So let's do that. So to the top we go. So what's happening on the top? X times x, x squared plus negative 8x, boom, boom. Negative 8x squared, negative 8x over. Again, the bottom, who cares? Just copy it down. We're not messing with the bottom anymore. Oh, I need more room. That's right. This one's going to do an extra special trick at the end, isn't it? I forgot. All right, let me write it a little smaller. X squared minus 8x squared minus 8x over x. X plus 1, x minus 1. Now, x squared minus 8x squared. Notice all my work's on the top now. I'm done with the bottom, right?
7x squared.
That'd be negative 7x squared minus 8x. Good to there? Now the last thing you're supposed to try to do on the top. What was the first thing I did? Think about the first, they're like bookends, that you begin and end the same. What was the very first thing I did? I looked here and I factored. The process begins with factoring denominators, right? All my focus was on the denominator. And it ends with trying to factor the top, the numerator. See how it begins and ends with factoring? Factoring is all over the place, huh? That's why we spent a whole chapter on factoring. So factoring begins and ends these problems. You begin by factoring denominators. You end by trying to factor the top at the very end. Again, we're done with the bottom. How do we factor? Is the top factorable? It is, and that's weird and rare. Usually, the top will not be factorable. Probably on today's exam, the top is not. I don't exactly remember, but I bet that there's nothing factorable. Usually this skip. Usually you skip this. This is a super hard problem. I try to put the hardest ones on the practice exam, so you've seen the worst of it. So there's probably not anything this hard on the real exam today, where you need to factor the top at the end. They do have x in common, don't they? And then that's minus 7x minus 8, right? What's in common? They have both. These guys both have x. Take it out. And that makes this cancel, doesn't it? And so here is the answer, which is not there after all that. None of the above. No, it's not quite C. See how C has a plus?
It's easy to X. You only have an 8 instead of 8X. It just can't be
For C. C's close, but it's not quite
B
right.
is the first one.
B's close as well. B is like what I had here, huh? But it wasn't quite simplified. That's an awfully difficult question. Probably not anything that hard on the desk today. But now that you've seen that, you can handle anything, right? Good on that? Questions I can answer on that one? We devoted a lot of time to that. We better. Okay, so number 12. What's in the middle? Minus sign. Going to be harder. That means, right? Plus and minuses make things hard. So what do you do when there's a minus in the middle? Remember I said never subtract? On the yeah, boom, boom. Hits both those, right? Remember that? Never subtract. Let the minus sign distribute to the upper right. So what do I get? 6x plus 7y plus minus 2x minus 2y. Everybody see what happened there? See how it hit both those in the upper right and they're both negative? Both 2's became negative 2? So write yourself in a 3x5 card, right in the corner, never subtract. Never subtract. Any subtraction in the middle, there'll be 1 or 2, probably 1, distribute to the upper right away. Changing all the signs in the upper right. And now the minus is gone, so there's just plus in the middle, right? When there's nothing in the front, you know that means plus. The minus is left. So there's nothing in the front, which means plus. So everybody see that? The minus distribute to the upright, changing all signs. Okay, now what? What should be my thought on this one? Yeah, looking at those denominators, adding, you got to make the bottoms the same. So I look at these two denominators. All my thinking is about the denominators now. Got to make them the same. Not even going to think about the top. I don't care if there's a weird monkey up there. I'm just focused on the bottoms, thinking I've got to make those bottoms the same. Okay, do I need to factor those bottoms? Denominators. No, there's no pluses or minuses down there. No need to factor. It's just jump into the give them what they're missing right now. Everybody see that? How I don't need to factor those denominators? Whereas the last one had pluses and minuses on the bottom. I needed to factor those denominators. Right? Pluses and minuses do the hard stuff. Okay. So give them what they're missing. What's this guy missing that the other one has? He has a 2, x squared, and y. He has no number in the front, a plain x, and y squared. What more does this neighbor have? An extra y. That's all he's got. Right? This neighbor has y squared. He only has 1y. Otherwise, he's got more of everything else. Does that make sense? This guy, what does this guy need that the other one has? 2 and x. Because he's only got 1x, this guy's got x squared. Everybody good with that? Give them what they're missing. All right, let's keep going. Now I'm done with the denominator because they're common, aren't they? I'm totally done with the denominator because they're. In fact, what is the common denominator? Put this one together or that one. They're going to be the same. 2x squared y squared. Right? Either one. They're both the same now because I gave them what they're missing. They filled in the same. Okay. Boom, boom. So now all my attention turns to the top. I have made the denominators the same. Done with the bottom. Now all my work goes to the top. Distribute on the top. 6xy plus 7y squared. This 2x, boom, boom. Minus 4x squared minus 4xy. Good to there? And last thing in the top, any like terms?
Yes.
6xy minus 4xy, huh? That'd be 2xy. As far as order on the top, who cares? Doesn't really matter what order you have that stuff in. There's my answer. I'm not even going to try to, well, you should try. Remember the last thing, what's the last thing we're supposed to try to do? Try to factor the top, right? Nothing's going to factor. See, that's probably every problem today. Nothing's going to factor at the end. And they don't all have an x. They don't all have a y. There's not a number that goes into 2 and 7 and 4. Right? So we're done. This is our answer. The order doesn't matter. Just find the one. Is it C? Yeah, it's C. No. C has the wrong denominator. Oh, did I mess up on the denominator? Oh, I lost the square there. It's C. Good? Question, Danielle?
Could you cancel the 2xy with the 2xy on the bottom, leaving just xy?
What does this guy say?
Oh, no.
I'm a big glued Costco package. You go like this or you don't touch me. Right? So I tell my daughters to say to the young men, you get the ring on the finger or you don't touch me. It's one or the other. It's a good rule for fractions as well. Right? They're plus and minus together. It's one unit. All right, 7x over 5 plus 9 equals 1/8. So now we have an equal sign. See how things have changed a little bit? Now we're talking equal sign. All right, so let me write this one out for us. So 7x over 5 plus 9 equals 1/8. Okay. So with an equal sign, what changes when there's an equal sign? What's that? Just left to right. Yeah, left to right. Yeah, tops only, huh? So let me write that somewhere for you. So here, if this helps. Equal sign. Here's a way I help people remember it. I don't know if I mentioned it this semester. Equal sign easier, EE. If that helps. Have I said that? I can't remember. Equal sign. So when you see equal sign problems, you want to think easy. Now, what's easier? Tops only. You don't have to do like the bottom. Just the top. Why? Because I'm not thinking top bottom. I have an equal sign, which means I have a left side and a right side, of the equal sign. All of my thinking is do the same to the left that you do to the right. I don't care top bottom. I'm not thinking top bottom. I'm not limited to only doing top and bottom. I've got a left and a right now. Whereas like over here, look at the difference. See this? You might say, well, that has a left and a right. Well, they're not equal though. That's not an equals in the middle. The left doesn't equal the right. So you can't say, oh, the left equals the right, so just do the same thing to the left and the right and they'll still be equal. Well, they were never equal on number 12. See the difference? If they're not equal, you can't do left right. So what? So I had to do top bottom. Had to do top bottom. Everybody see that? But now, with the equals here, the left equals. This whole left equals 1/8, equals the right. So if two things are equal and you treat them the same, they'll be equal afterwards, won't they? So as long as I do the same thing to the left, all the terms on the left, as I do to the right, then they'll be equal when I'm done. If I only do the top, that's okay. As long as I do it left and right. I don't have to mess with the bottom. These are easier, therefore. You don't have to mess with the denominators. It's kind of nice. So I hope that helps you. Put that in your 3x5 card. Equal sign, easier. When you see the equal sign, when you go, oh, these are easier, just do the top, top, top. Don't need to mess with the bottom. Okay, so what am I going to do to the top, top, top? Common denominator. So we still use the common denominator. We just put it only in the top once we found it, So what is the common number? We got 5, we got 8. It's 40. You can just multiply them together. 5 times 8 is 40. What do I do? Top, top. Even on the 9 there, It's got to be all of them because the left equals the right. Equal treatment for everybody. They'll still be equal. Is that good? Equal sign easier. Top only. And now what do I do? What's that? Well, 40 times 7x over 5 right now. And so now what am I going to do? Going to cross cancel, right? We good with that? Because it's really 40 over 1. So 5 goes into 40 8 times. And you cross cancel and the leftovers multiply. 8 times, that's a 7x, 8 times 7x, 56x plus. Good so far?
I think you-
Everybody see what happened there? So the 5 went into 40 8 times the leftover 8 and 7x multiplied. So you cross cancel, multiply what's left over. Next one. 9 and 40, they're both over 1, aren't they? Neither of those is a denominator. So there's no canceling. They just multiply. 4 times 9 is 36. 0 at the back. 360. Good so far. What about on the right side? Over 1, 8 goes into 40, 5 times 5. Look at that, no more fractions. See how they're easier? Equal sign problems are easier, equal easier, because you only have to do the top, right? Top, 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 and there's no more fractions after one step. So that'll help you remember that when you see these today. Equal sign easier, only the top, 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 top.
Found the LCD and then you just multiply them all by that.
That's right. Just find the LCD, top, top, top. None of that, give them what they're missing, all that stuff. No, just find the LCD, top, top, top. Equal sign, easier.
I think you can only do 2 numbers.
And there's no more fractions now. So now how do we finish solving for x? Subtract that 360. So 56x equals, kind of getting messy there. What is that, minus 355? And then last step, divide by the 50. Is that nice or is that ugly? What is that? That's just it, huh? Minus 355 over 56. Okay, there it is. D.
You gotta shift.
Try to reduce any fractions, though, on the test today. That 5 doesn't go into the bottom, and so I guess it doesn't reduce at all.
Is there a way to do that on the calculator?
Yeah, so you have a fraction button, right? So most of you have a fraction button, don't you? So yeah, the Casio natural displays for sure do. Right? You all know how to. Do you know how to enter fractions? Yeah, I can reduce them for you automatically. There's the thing is hit that button. So automatically. Hello. Go. So yeah. So if you there's somewhere. I look at it myself over there. Yeah. So over here, at least on the Casio natural display, there's a see that fraction maker right there. That'll so you just push that button, bonk, and it's like ready to make fractions. What did we have? We had 355 or 56. Let's go 355 and then hit the down there. I'm gonna hit this down, jump down to the bottom. I don't care the negative. I know it's negative, whatever, who cares? And just hit enter. It did nothing, which means it's not reducible. So if it changed it not at all, it's not reducible. Now if you put in here, let me do another fraction, something that is just like 8 over 12, and hit enter equals whatever. 2/3. See how it reduces it right away for you? You can hit the SD button. See this SD button right here? Down here, this SD. That changes the form from decimal to fraction. So you hit that. See, change it to decimal. 0.6 with a bar means 6 repeating. Or that shows it longhand. Hit it again.
Make it a mixed number.
And then in the shift, I think you make it mixed. I think you're right. Shift, boom. Oh, it's not. 2/3 is not a mixed number, so it did nothing. But yeah. Anyway, right? So different calculators have different ways of doing that. But some of the TIs will do it too. On that, and it's a different button though. So try to look for like on the TIs. I think I saw it too. Just the TI, yeah. So I think yeah. So like if you have one of those TIs, it's just not quite as user friendly, but it'll do it. Where is it? Right. It's this. See this fraction? And that's a mixed number, and they put the normal fraction above. So I think you hit 2. Wait, turn it on. Hit 2, and then you hit just hit that button. Yeah, that's the fraction. That's the weird. So I just hit this button. 2 fraction. That means 2/3. It just writes it sideways. It's not quite as user friendly, but that means 2/3. It knows that's 2/3. Well, let me. That wouldn't help. Let me clear one. Let me do 8/12 again. So 8 fraction 12. So instead of 8 divided by 12 on this calculator, I do a fraction button 12. So then it knows that's a fraction. It knows that's 8/12. If I hit equals now, it'll probably reduce it. Yeah, 2/3. If you want to change it to decimal, see this FD down here, fraction to decimal. You just hit second FD. Boom, it changed it. Change it back. So most calculators will do it one way or the other. Grab me after if you want to see how to do that. All right. So, where are we at? So, did we finish? Oh, we're on 14, huh? So we finished 13. Let's go to 14. Okay, 14. So, equal sign. We think easier. Which means what? Top, top, top. I mean, not super easy. Still got a plus in the middle. It's going to be a bit of work. But easier than if they didn't have an equal sign. Equal sign are easier. In a minute, we're going to go top, 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 right? We're not going to go top and bottom or anything like that. What do you got to do first, though? What is this telling you have to do? Yeah, you got to factor denominators. That's always required when you have pluses or minuses in denominators. You got to factor. So let me factor that one. Let's take out a 4, huh? We good there? So far, so good. I just factored the 4 out. I just took out what's in common. They both had a 4 in common. So we always start with, when we have fractions, you got to factor denominators. Okay, now, what's the next step? Equal sign easier. Here's the wall, left side, right side. LCD. What is the LCD?
4 times x minus 4.
Yeah, 4 and x minus 4. The 2's not a denominator. Don't be thrown by the 2. He's not under a bar, is he? So the 2's not a denominator. The common denominator is a solo 4 and an x minus 4 glued package. We don't need both x minus 4s, right? We're only buying one of everything. So what do you do with it? Top, top, top. Equal sign problems are easier. I'm not going to do anything on the bottom, am I? It's just top, top, top. Forget about the bottom. Why? Because I have a left and a right. All my thinking is left, right. I'm not thinking top, bottom. I'm thinking left side equals right side. Treat them the same, they'll still be equal. I just treated them the same. I just gave everybody a 4, x minus 4. What do we do now? Cross cancel, multiply whatever's left over. So what cancels? Boom, boom. What's left? 4 times 1, that's just 4. Boom, boom. What's left? 4. Now here, do I cancel 2 into 4? No, these are both over 1. They're not denominators. There's no cross canceling happening. There's nothing low to high there, is there? It's just 2 times 4 is 8. And then the 8 distributes through the x minus 4. 8x minus 32. The other side's just 8. 4 and 4 is 8. Everybody see what happened there? Right? Just 2 times 4 made 8. And the 8 distributed through the x minus 4. 8x minus 32. Now it's just solve for x. No more. Look at that. No more fractions, huh? Equal sign problems are easier. The fractions vanish after the first step, don't they?
You didn't multiply
The 2 to the x minus 4 also?
at the very top, the 2 and the 4, that would be the 8.
Right.
And then the 2, you didn't do 2x?
Right. So I did not let the 2 go there, did I? Because it's the same reason I showed you a minute ago when I said, how do you do, 2 times 3 times 4? Remember when we multiplied 2 times 3 times 4? When you're multiplying 3 things, you don't let this 2 go to both.
Right.
It's not distribution. Everybody see that? That's what's different. You just go 2 times 3 is 6, times 4 is 24. As we all know, you only do the first 2, huh? That's what we have here. A 2 multiplied by a 4 multiplied by an x minus 4. 3 things multiplied. You only do the first 2. Or you could do the first and the third. It doesn't matter. You only do 2 of them, though. Right? That's not distribution. What you're confused on when you look at that and you think, wait a minute, we've done that before. No. We only do that when there's pluses and minuses separating things. So in other words, if I had something like, if I had 2 with 3 and 4 separate, yeah, then the 2 would go to both. Right? Distribution only goes over the waters of pluses and minuses. Not 3 things times. That's just do the first 2, finish it off. Right? Everybody see that different structure? Right? This is 3 things. You just multiply the first 2. These are 3 things times. So we just do the first 2. I know it looks similar. Okay, so where are we at then? So that's 40 is 8x. Last step. Divide by 8, x is 5. Oh, it's none of the above. After all that. Is that good? Well, that's everybody okay with the question about 3 things multiplied up here? You just do the first 2. It's a good question. I know it's tricky. Contractor Sam Tuckett, 11 hours to construct a wall. It takes Lowell 6 hours. How long together? All right, so I hope you have on your 3x5 card the working together. So if you don't have it, put it right now. Make that card, rip out a piece of paper. It's about 3x5 and put that stuff on it. Working together. So what's the working together formula? 1 over B is 1 over X. On the right side is always going to be the X. Good? So 1 over 11, 1 over 6 is 1 over X. Just like that. Working together. It'll be one of them on today's test. 1 or 2? Probably 1. 1 over 11 plus 1 over 6 is 1 over X. So, is that good? 1 over A, 1 over B, 1 over together. Okay, now, it's equal sign. Equal sign are easier. So I'm just going to go top, top, top. What's the LCD?
66.
Good. And don't forget the X. Good job, you guys remember the X. It's not just 66, it's 66X. Common mistake I've seen over the years is just to do the 66. That'll mess you up. So it's 66X is saying, I'm in the denominator too. Don't forget about me. 66X. That's all denominator stuff, isn't it? 66X. Okay, that's important. You will get the wrong answer if you don't remember the X part. All right, so how do we go from here now? Cross cancel. Multiply what's left over. 11 into 66. 6 times, what's left over? 6 times X? 6X. 6 into 66. 11 times, what's left over? 11X. X cancels X. 1 times 6, 6. There we go. 17X is 66. Last step, divided by 17. Do they want a mixed number?
Yeah, they want to mix it
Yes,
up.
3 and 6.
Yeah, I would just use my calculator, honestly. I would just divide this on my calculator. I would just go 66 divided by 17. What is that? 3.8882, whatever. And then I'd go, hey, this one's 3 something. Is that the same? I don't know. Let me see. Take 15 divided by 17 on my calculator. You can just convert that to decimal. What is 15 divided by 17? Yeah, that's it. That's 88.882, whatever. So that must be it, B. Everybody see how I did that? And I never even messed with changing to mixed numbers. I just made them both fractions. I made them both decimals. Not too quick. Everybody see what I did there? So I just took my answer, 66 over 17. I just divided it in my calculator. Got 3.882 and looked over and went, well, the only one with a 3 is B. Maybe it's B or maybe it's none of the above. So I just divided 15 by 17 in my calculator. Sure enough, the decimal part came out right. And I know it's got the 3. So it's 3.882, just like my decimal answer. Don't even need to mess with mixed numbers. But you got that button if you want to change the mixed numbers also. But either way, even without that fancy button. Good. 15 problems. All right, Chuck and Dana, Chicago. All right, what formula do we use on these travel ones? The dirt formula, yeah. Distance equals rate times time. I was just reminding my pre-calculus students of the dirt formula an hour ago, and they'd all forgotten. Distance equals rate times time. All right, so here we go. Remember, we got to get, the left 4 boxes. So we have Chuck and Dana. So what does it say? Chuck, 114 miles. Is that a distance, a rate, or a time? That's a distance for Chuck. Dana, 96 miles, distance for Dana. Chuck's rate, we're talking rate for Chuck now, 6 more. Chuck's rate, 6 more. X plus 6 in the rate box for Chuck. The other box? X. Remember, there's always a plain X somewhere. So Chuck is 6 more. That was X. We got our 4 boxes. Good so far. What do you do on these dirt problems once you've got the left 4 boxes? How do you get the right 2 boxes? Left over middle, huh? You divide. Because it comes from the formula, distance is rate times time. If you want time, you divide by rate, don't you? Time is D over R. So it's D over R, it's left over middle. So it's 114 over X plus 6. It's 96 over X, isn't it? The right 2 boxes are always left over middle, left over middle. Might be good to put this whole thing on your 3x5 card if you have room. All right, now what else do we do now? We grab out these two boxes. Now, are they equal? How do we know? Same time. Remember, these are both time. They're under T. They're same, which means they're equal. Yeah, they're equal. Now, some of the other problems could be on the test today. They would say, Chuck does his thing in 3 hours less time. Or Dana, 2 hours more time, or whatever. What do you do if they tell you that one's more time or less time than the other instead of same time? Same time is equal. That's easier. Yeah.
Whatever the difference is would
Be the number. Yeah, if they told you these are one's more, one's less, whatever, either way it means they're different, right? If they tell you they're different, they're not the same, then you make a difference. You subtract them. If they said, one's 3 more, one's 2 less, I would go, whatever, they're different by 3. You subtract them, their difference will be 3 or 2 or whatever they say the difference is, whoever's more or less. Remember that? We had a couple of those in the homework. Anyway, this one's easier. They're same. They're equal. Cross multiply. 114x is 96x plus 6. Distribute. 114x is 96x plus some number that's too big for me.
576.
Thank you. 576. Okay, how do we solve this equation? Here's the wall. X is saying, I want to be alone. But X is in 2 locations. Get rid of one of them, huh? Yeah. Subtract 96x from both. Gonzo. It's at 18x. 576. Last step. Divide by 18. Hopefully that's a nice number. 32. That's nice. So X is 30. Now careful. Wouldn't it be a bummer to do all that good work on today's test and then fail to read the last question carefully? Because it's not just X. I mean, it might be. It usually is. But be really careful. Look at the question. It's not always X they want from you. Remember, X is the key. We can unlock any of these doors now. Make sure you're unlocking the correct door. What do they want from you? At what speed does Chuck travel? Chuck travel. Where's the Chuck travel speed box? Chuck rate. Boom. It's there. So it put that 32 in first. 32 plus 6, it's 38. Oh, and they had the 32 there. They baited the hook and threw it in the waters of our test. Right? But we didn't bite. Right? And don't you bite today. It'd be a bummer, wouldn't it, to do all that good work and then just bite on the wrong answer? Don't just grab X right away when you're done with a word problem. Go back and check out what they want. They want Chuck's rate. That's at 6. So it's 38, not 32. It's 38 on that. Good on that one. Questions? All right, so 17. These are complex fractions. There'll be 2 of them, just like in this practice exam. There'll be 2 complex fractions. What do you do with complex fractions? Which means fractions over fractions. See what I mean? See how it's fractions over fractions? So what do you always do? You just find the LCD for all the denominators involved, which means consider him, and consider him. Consider all the denominators and say, what will handle them all? What's the common denominator for all those guys? What do 4, 8, next? 8x. You're good with the 4 and the 8 go into 8, huh? Right? 8 handles 4 and 8, and then the x. So 8x. What do you do with the 8x? 8x, 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 8x. I did it top and bottom. There's no equal sign here. So I'm back to top bottom, aren't I? I gave it to all the terms on the top, all the terms on the bottom. So I'm not changing the fraction. I'm treating the top and the bottom the same. So whatever happens will be equivalent to the original. All right, so what happens? 8x times 4, 32x. What happens here? This is over 1. These really are 8x is over 1. I should probably write it that way. Yeah, did everybody see what happens there? The x cancels the x. Left over 2 times 8, 16. Am I going too quick? Right, you cross cancels. Everybody see? So I found the common denominator. I looked at all three denominators, x, 4, and 8, and said 8x. 8x over 1, 8x over 1, 8x over 1, 8x over 1. And then cross cancel. Right here, you might wonder, why did the 4 and 8 not cross cancel in that first spot? Because, yeah, they're both over 1. Neither of them is a denominator. This is 4 over 1. This is 8x over 1. They just multiply top with top there to make 32x, huh? But here, this bottom x canceled with the top x, right? Cross-canceling means bottom to top, right? Here, it's just kind of messy. Let me write it a little. I wrote it too big is what I did, huh? So 8x over 1. Let me keep this right. This is 8x over 1. 8x over 1. So right here, what's going to happen here? 4 goes into 8 2 times. 2x squared. Everybody see that? See how there's a 2 left over and 2 x's, 2x squared. And the 4 went into 8 2 times. Everybody see that? And then here, 8 into 8. All we're left with is x. Now there's one more step, but are we good to there? It's much cleaner now, huh? Now, what could we do now?
16.
Yeah, factor the 16 out of the top, huh? Whenever we have fractions, we factor if we can. What does that leave? 2x plus 1. Everybody see that? If 16 times 2x be 32, 16 times 1, that'd go back, wouldn't it? Everybody see that? So I took out that 16. What about the bottom? So we're factoring. Well, how do you even know? You might wonder, like, there's so much to remember. How do you know? Remember the plus sign? Pluses and minuses in a fraction need to be factored, don't they? They need to be factored. And same thing down here, right? So we got to factor the top, factor the bottom. What do these guys have in common? X. What does it leave behind? 1. Because if you multiplied, it would go back. And then what happens? Boom. 16 over x. There it is. You see that? Good there. All right. So I'm going to move on. 18. We can do 18 right here. 18. What's up with 18? Same thing. It's fractions over fractions. So you want to look at all these denominators and say, okay, what's the common denominator for all of them? First off, let's do the numbers. We got 3, 3, 3, 9. What number is a container? That's what a common denominator is, right? It's a container that can hold any of them. 9. 9 will hold them all. What about x? What power of x do we need? X to the third, the biggest one. That's why we need the biggest one, right? It's a container. 9x to the third is a container big enough to hold them all. So here we go. 9x to the third over 1. 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 Is that good? Like that. And then we cross cancel. So 3 goes into 9 3 times. X cubed cancels x cubed. 3 plus. Is that good? We're almost done. I know you're anxious to take that test. We're almost done. So everybody see what happened there. We'll make sure it'll be a happy test. 3 into 9 3 times. X cubed cancels x cubed. 3 times 1 is 3. Oh, is it minus? I can't even tell. I crossed it out. Okay, thanks. Yep, it's minus, huh? All right. And then 9 cancels 9. Now, what about x cubed over a single x? It leaves x squared. And 4x squared? The 9's gone, right? The 9 canceled.
Oh, yeah.
So there's just the 4 left. 4x squared. Good on the bottom there. On the top. Now let's go to the bottom. 3 into 9 3 times. X cubed over regular x. 3 times 4 is 12. X squared. Is that too quick? Did you see that? 3 went into 9 3 times. 3 times 4 made 12. And then x cubed over x is x squared. plus. 3 goes into 9, 3 times 4, 12. X cubed cancels x cubed. There it is. By the way, this one doesn't factor any further. Remember how the last one we had to do the extra factoring? Look at the top. You can't factor that. They don't have anything in common. There's no way you can do 2 parentheses. No way to factor that.
No, because they're pairs, they're Costco pairs.
Yeah, there's nothing you can do with it. Everybody see that? The bottom can factor a 12, but there's no use in factoring the bottom if the top isn't going to factor, because you want them to both factor and cancel. The top doesn't factor. Everybody see that? No way to factor that top. So we're done. There's the answer.
It would be just 12 parentheses x squared.
Yeah, we will not even, that's true. That is true. But we won't even bother to write it. Yeah, because it doesn't make anything cancel. The purpose of factoring is reduction. And if it doesn't reduce, we don't even show the factoring. Yeah, so we just leave it just like this. Yeah, good question. Don't be thrown off. Don't take out that 12 and go, oh, so it's not this one. It's really none of the above. No. There's something you don't know if you're doing that. And that is the fact that factoring, the purpose of factoring is reduction. So if one part factors, or even if both factor but nothing cancels, ditch it. Go back to the way it was before you factored. Factoring is only beneficial if it leads to something. It's a tool. It's like, it's like the engine in your car. You don't go, I just got an engine. Well, engines are no good unless they're in a car and you can go somewhere, right? That's what factoring is. It's a tool to get something done. Factoring is to make things reduce. So if I factored out that 12, nothing would reduce with the top because the top doesn't factor. So leave it as it is, and that's why it's D. All right. Varies directly, right? Is that what it says? Oh, directly. So what do we do with varies directly? There'll be one directly, one inversely on this test. Directly, yeah. A over B is C over D, huh? For varies directly, it's the fraction. D divide, yeah, that's what I said. D divide, huh? Directly divide. DD, directly divide. Excuse me. Okay. So, where are we at? So, what are we going to divide? Okay, so it's the mass varies directly as volume. So M over V is, the mass is 64. That's confusing.
Yeah,
The mass of 64. So that goes on the bottom. Is 128. The 128 goes in the top. That's tricky. The way they did that. Oh, no, I changed that problem. After you showed it to me, Danielle found it. It was harder. And I made it easier. Yeah, I changed it because of what you showed me. Okay, is that good? See how that kind of tricked around there? Right? Everybody see that? What might help is, mass is grams. Do you know mass is grams? And cubic centimeters is volume, so 64 has to go on the bottom. Okay, then we do diagonal. Remember, 64m equals 128v. And what do? You solve for the m, divide by the 64. Right? M equals that 2v. 2v. You good with these? Last step. 125 is the v. So it's 2 times 125, which is 250. There it is. See that?
And it doesn't. You could have put V over the M, right?
You could have, but then you'd have to be consistent on the other side. Yeah, just be consistent. So yeah, either way. So I put M over V. Now you had to be careful with the words, right? Because look at the words. The mass is 120. See if you cut out those. Maybe it'll help if I say it this way. It says mass is 128. So that's mass. Mass is 128, huh? And 64 cubic centimeters, that's volume. That makes sense? A little tricky, huh? The way they switched they made a complex sentence is what they did. Yeah, I changed it after that. I made it easier. Yeah, after you printed it out early, huh? Yeah. Yeah, because I changed it. It was tricky. Yeah, I won't give it that hard. It'll be more like this on the real deal. All right. Okay, what do you do with varies inversely? Yeah, inversely, A times B is C times D. So it's X times V is 45 times 6, huh? X times V is 240 and 30, 270. Good. Solve for X. Divide by V. X is 270 over V. Last step. V is 30. Put in the 30. Whoops. So X is 270 over 39. X is 9. Boom. X is 9. So inversely, they're multiplied, right? We get with only 20? Is that it? Good. 20 easy questions.